lesson is called Solving by Substitution. Now, when we solve by substitution, what we're doing is we're learning about how to actually solve linear systems by reinforcing what we learned yesterday, by just substituting, right? But we're going to understand the symbols for that thing, for the substitution, and then we're going to show the progression of the system when rearrangement occurs. Then we're going to reinforce the checking one more time. Okay? Because of the work that you did yesterday, you're a little bit ahead. So now we're just going to reinforce what we learned. We're going to get really good at, because you're going to end up doing it for the rest of your mathematical lives. I apologize for that, but it has to be done. Now, here we go. So this is the lesson, and I want you to put today's date on the top of the sheet, and then I want you to write down, highlight this stuff that I have here, okay? So when we're solving a linear system, right, we solve it by substitution, okay? We rearrange one of the equations, okay? And we sub it into the other. And we sub the right side of the rearranged equation into the appropriate variable of the other. Okay? And I want you to write down this basic equation, and I'll just wait for you, and then we'll do the problem. Start by labeling the top equation number 1, and label the second equation number 2, and then put a curly brace beside the two equations to say that it is a system. Remember, a system is two or more equations. Now that we've done that, what I want you to do is I want you to think about which one of these equations is the prime candidate for rearrangement. Is it equation 1 or equation 2? Quickly. Equation 2, because y is already by itself, so we can isolate quickly. So we're going to get the following. And y is equal to negative 4x plus 7. So remember, this is still a system, and label this equation 1 and equation 2. Now that you've done that, what I want you to do is I want you to tell me what you're doing. We're going to sub equation 2 into equation 1. Okay? And when we do that, we're going to get the following. So we get something like this. We get 3x minus 2. Wherever the y is, we replace it with a bracket, and we put the contents of y, this stuff here, into the bracket. So I'm going to put minus 4x plus 7. Now, this is where I want you to start thinking about distribution. We spent all that time on distribution because of problems like this. The 2 that's in front is really negative 2, and we need to distribute the negative 2 into the bracket. By doing so, you're going to get the following line. So we get this as our solution. Now you're going to collect everything on the left side, collect all their like terms right away. So you should get 11x minus 14 equals 8. Now that I've got that, you're going to take your minus 14, which is on this one side, and move it over. So we got 8 plus 14, which is 11x. So 11x is equal to 22. And x is equal to 22 over 11, which is 2, which is what we expect. Now that we've got x is 2, we have to actually go and back substitute. So now we're going to sub x equals 2 into what equation, guys? Sub x equals 2 into what? Yes, into equation 2. So we get y is equal to negative 4 bracket 2 plus 7, which is negative 4 plus, no, it's negative 8 plus 7. So y is equal to, I don't know, y is equal to what? Negative 1. Excellent, guys. So we're not quite done yet. We're going to have to do a check. So what I'm going to do is I'm going to resize this information, then we'll do the check on this one page as well. Remember that when we do a check, you need to check both equations with the solution, which is 2 and negative 1. All right, so here we go. Let's group that, and now we'll just shrink it. All right, so now that we've done that, what I need you to do is I need you to do the checks for equation 1 and equation 2 with x equals 2 and x equals negative 1. Okay, so now this is our check. So we're checking to see if 3x minus 2y equals 8 works with x. The solution xy equals is 2 negative 1. And we start with our ls equals 3x minus 2y. We do our substitution. 3 times 2 minus 2 times negative 1, which gives us 6 plus 2, which is 8. My left side is equal to 8. So we now say since the left side equals right side, therefore solution is 2 negative 1. Do the same for the... Yes, John, that's right. So when we go back to our original, we have to always go back to the original equations. For the second check, you're going to use 4x plus y equals 7. That's this equation right here. So now by doing your second check, you're going to get this solution. Now at the very end, after you've verified that both checks work, what I want you to do is I want you to say what our final thing is. So now you're going to say, therefore, the solution is we can write it like this, xy equals 2 comma negative 1. Now sometimes you might have different descriptions of x and y. Maybe x could be the money that's in your GIC and y could be the money that's saved in your TFSA. And what you would do is you'd explicitly say the amount of money in the TFSA is this, the amount of money in the GIC is this. Got it? All right, let's move on. So now what I want you guys to do is I want you to refer to the note that you just wrote, and I want you to do the same problem again, and at the very end make sure you check your solution. And I'll show you my own solution in a moment. First, choose which equation you're going to solve for. You're either going to solve for x in 1 or y in 2. I chose to solve for x. Now let's do our substitute. So now we get this for our substitution. Let's distribute. So now we have this, and now when we collect our like terms, we have 51 minus 13y equals 12. So now we have 12 minus 51 is negative 13y. So getting rid of the 13, we divide by negative 13. And this is eventually going to be negative 13. This part here totals to be negative 39. So our final answer should be y is equal to 3. So now Once we get y equals 3, we must back substitute. So now we're going to sub y is equal to 3 into equation 1. And we're going to get x is equal to 17 minus 4 times 3, which is 17 minus 12. And then we get x is equal to 5. What I want you to do is I want you to do your check on your own for this one. Make sure you do your check. All right? All right, so your first solution or your check is going to be this 4x plus 4y equals 17 with the check of xy equals 5, 3, and then you're going to get this left side, right side, and basically it works. And then we go and do our second check. And yes, it does work. So now let's move on to the next problem. All right. The next set that we're going to do, we're not doing any proving, any checking. All you have to do is solve. In this case, we have equation number 1 and equation number 2. There's no rearrangements to do right away. You're just letting y equal y. In this case, we just start right away. So we say 2x plus 1 is equal to 5 minus 4x. Now, literally, you're just going to say sub 1 into 2. Right? Isn't y equals y really meaning 2x plus 1 is equal to 5 minus 4x? Can you solve for that? Go for it. Let's go. So we go through our solution. We get x is equal to 2/3. The reason why you get 2/3 is because not all numbers are nice. All right? You sometimes get repeating numbers like 2/3, or you may get numbers like 2.5. Okay? Leave your answer in this form. Don't go any farther. Now what I want you to do is do your back substitution. So now we're substituting back into 1, so we're going to get y is equal to, well, 2 times 2 over 3 plus 1, which is 4 over 3, plus 1, which is just 4 over 3 plus 3 over 3, which is just 7 over 3. So y is 7 over 3. And all you have to do now, since we're not checking, is we're just going to state the solution. Therefore, the solution. Now, you can write solution as this for me if you're rushing on a test. And you're going to write x, y equals 2 over 3, 7 over 3. And we're done. Moving on. Next problem. Oh my goodness. Fractions. Who hates fractions? Put your hands up. My entire class put their hands up. I'm putting this on YouTube for prosperity. So this equation, we're actually going to say that we're looking at the first equation. We can easily isolate x. So let's do that. So we got x is equal to -1 plus y over 3. All right, and then we have the second equation is x over 4 plus y over 2 equals 1. Now, here's the cool part. There's 2 ways of doing this. You're right, guys. I made a boo-boo. This should be minus y over 3. No excuse today. I actually have coffee. As usual, we'll make sure we label each equation, equation 1 and equation 2. And now you're going to sub equation 1 into 2. We could have made equation 2 a lot easier by just multiplying everything by 4, couldn't we? We didn't. You could have done that as part of your simplification, but let's see if you can handle fractions. So we're substituting. Here we go, guys. So we get this, and now we're going to substitute the -1 minus y over 3. So here's the ugly part. You guys don't like fractions, right? Let's multiply by the fraction. Let's multiply by the LCM. That'll get rid of this. So now we're going to end up with, we're going to use 4 times this whole part, and 4 times this, and 4 times this. So now we get some cancellation going on here. 4 divided by 4 is 1, right? 4 divided by 2 gives us 2, right? And 4 times 1 gives us 5. So now our simplified version of this whole thing is this. Negative 1 minus y over 3 plus 2y is equal to 4. Oh my goodness, that's easy. Make your life easy. Collect all the regular numbers. All right, let's do this. So we're going to get negative 1 minus y over 3. 2 over y becomes 6 over 3y equals 4. Now that we've got that, collect your like terms on the left side. So we get negative y minus 6y over 3 is 5y over 3, and a minus 1 in front. Move the 1 to the other side, and we get 4 plus 1 gives us 5, and we have 5y over 3. All right, now we have, so we have 5y is equal to 5 times 3, which is 15. So 5y is 15. Now what? Exactly, we divide both sides by 5. So y is equal to 3. So now we're going to go back and do the back substitution. So now we'll go back and do the back substitution. I'm going to make sure that all of this is on one screen. So after all our work is done, we just have to do our back substitution. So sub y equals 3 and 2. So we use the bottom one to solve, we'll call this equation 1 and equation 2. Or what you do is do a little aside here and show me how you solve for equation 2. So we got 2y is equal to negative 4x plus 10. Divide both sides by 2, so you get y is equal to negative 2x plus 5. And that's what you put as your... And then continue on with your calculations, guys. Good? And continue on with your calculations. So that's what we get for x. And now what I need to know is what y is. Sub it into 2. And y, after doing your calculations, you get y is equal to negative 1. No check. So now we have this new system. Solve for one of the y's. All right? Oh, yeah, you could do both. Awesome. You could solve both if you want and then make them equal, or solve for one and plug it in. It's up to you guys. Go for it. So there we go. Do our substitution. Sub 1 into 2 equals 14. So now let's distribute. We have 4x minus 3 times negative 5 over 2 is 15. Positive 15 over 2x minus 9 equals 14. Now, I hate that fraction. So we're going to multiply all these numbers by 2. So times this by 2, times this by 2, and times this by 2, and times this by 2. Simplify your work, and we end up with 8x plus 15x minus 18 equals 28. 8x plus 15x is 23x minus 18 equals 28. So 23x is equal to 46. So go through the math. X is equal to 2. All right. Back substitution, we're going to end up with this. And that's what we get for our final solution. And your homework for today is going to be this stuff here. And I have some extra questions that I'm going to put on as well. So if you're not here, you're not going to get your work done. All right, I lied. There's your extra challenge.